students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the chapter 12, electricity of class 10 CBSE. So in this chapter, the main topics which we have to study are charge, current, potential difference, circuit diagrams and symbols, Ohm's law, resistance and heating effect of current and the electric power. So in this session, we are going to discuss about the charges and the current. Okay. So basically we all know that electricity is very much important for us. In everyday life, day-to-day life, we see that electricity plays an important role. Without electricity, we cannot even spend a single day. Okay. In our homes, right from the geysers, mixers, electric bulbs, fans, everywhere electricity is needed. And we all know that electricity is very much important for us. Now, in order to understand how electricity is coming at home, what is electricity, we should first understand what is a charge. Okay, what is a charge and what is current, and how charge and current are related to each other. For understanding electricity, we need to understand how the relationship is between the charges and the current. Okay. So let us start with the charge. Charge is the property of matter, and we already know that matter is formed with the help of atoms. So we can also say it is the property of atom. Okay, we can also say it is the property of atom. So let us quickly jot down the points for the charges. So the first point says it is the property of atoms. Okay, it is the property of atoms. Okay, now we already know that atoms are of three types. They can be proton atoms, can be protons, electrons and neutrons. Okay. So protons are the positive charges, neutrons are having no charge, they are neutral, and electrons are the negative charges. So accordingly, charges are divided into two types. Charges are divided into two types, the positive charges and the negative charges. The positive charges are the protons. The positive charges are the protons and the negative charges are the electrons. Okay, and the negative charges are the electrons. Okay, so the next point to be noted is that the SI unit. The SI unit of charge is coulomb. Okay. Okay. And the third point to be noted is that how much is the charge on one electron. It is given by minus 1.6 into 10 power minus 19 coulomb. Okay, it is given by minus 1.6 into 10 power minus 19 coulomb. So the charge on one electron is equal to this. Now the charge on one proton will be same, equal to 1.6 into 10 power minus 19, but instead of the negative, there would be a positive sign. Okay, with a positive sign, it becomes the charge on one proton. Okay, then the fourth point to be noted is that number of electrons in 1 coulomb of charge. They are given by 6.25 into 10 power 18. Okay, so the number of electrons are given by 6.25 into 10 power 18. Okay, and there is an important formula over here which we will be using in the numericals. Okay, and that formula is equal to Q is equals to NE. Okay, now what is Q? Q is the charge denotation. We denote charge with the help of Q. It can be also denoted in some books with the small q, but Q is the denotation for the charge. Okay, so Q is equals to Ne. Q is equals to Ne. This formula is important from the numericals point of view. From the numericals point of view. From the view. Okay. Now let us move ahead to the current. What can you understand by current? What can you understand by current? Current is the rate of flow of charges Okay, whenever the rate comes, it denotes that the time, in how much time the charges are being flowing. Okay, so the current denotes that in how many times, in how much time the charges are flowing. That is said to be as current, and current is denoted by capital I. Current is denoted by capital I. Okay. The points to be noted for the current are that the SI unit of current is amperes. Okay, is amperes. Smaller units are milliamperes and micro. The relationship between them is that 1 milliampere is equal to 10 power minus 3 amperes, and 1 microampere is equal to 10 power minus 6 amperes. Okay, so these are the units. Now, as we defined it, that it is a rate of flow of charges. So mathematically it is given as I is equals to Q by T, and sometimes the unit comes in the examination as coulomb per second. So coulomb per second is nothing but amperes only. Okay, coulomb per second is nothing. Coulomb is the unit of charge, second is the unit of time. So coulomb per second gives us the amperes. Okay. Then the third point comes, current is measured by an instrument known as ammeter. Okay. So here we have learned about the charge and the current. Now let us see with the help of a diagram how the charge and current are related to each other. Okay, so let us draw a diagram over here, a circuit diagram. Let us say this is a bulb over here. Okay, then it is connected with the ammeter over here. Ammeter symbol is, we will be learning all the symbols in this chapter, but right now you can understand that this symbol stands for the ammeter. Then there is a key over here, the key. Okay, let it be the key K, and a battery connected to, and a battery connected with the bulb. Okay, so this is our the bulb. This is ammeter, and this is key. This is battery, negative with a negative and a positive sign. Okay, so whenever this key will be switched on, the key will be switched on, the current will start flowing in the circuit. Now how the current will start flowing in the circuit? Actually, the electrons will start moving from here in this direction, and they will be moving and getting attracted towards this positive. Okay, yes, one thing we have left for the charges, that the like charges repel each other and the unlike charges attract each other. This point we have left out. Kindly note this point also over here. We will be noting over here the 6th point. Like charges repel, unlike attract. Okay, so negative and positive are unlike charges. So negative charge will be attracted towards the positive charge. Okay, so what will happen? The electrons will start moving from here and completing their path like this. Okay, so electrons will start moving and completing their path like this, and the current will be moving in the opposite direction. Electrons are moving in this direction, but my current will be moving from positive to negative. In the previous days, when much of the scientists have not discovered, then there was a conventional error over here. People used to consider the positive direction of the positive charges as the direction of the current, but nowadays that convention is overruled by the rule that the direction of the current is given as the opposite of the direction of the electrons. So the electrons, in whatever direction the electrons are moving, the current will move opposite to that of electrons. So now we understood that the charges flow and in what time, and because the current is the rate of flow of charges with respect to time. The charges are flowing, suppose they are flowing in 1 hour, so in that for the 1 hour we can find out the current easily by the formula Q upon T. So this is basically very important view from the exam point of view also, and from the numericals point of view also, that how the charges flow and how the current flows. So the direction of charge is taken opposite to the direction of the current. So let us jot down this point, which is very much important. Direction of current is always opposite to the direction of charges which are electrons, which are negative charges. Okay, negative charges. So today we have learned about the charge, the current, and what is the relationship between the charge and the current. This is very much important, this is very much basic, and this should be remained in the mind for the later classes also. Okay, so in the next session we will be studying about the potential and the potential difference. So please share my videos, please subscribe my channel, and if you have any doubt, you can ask me in the comment section. Thank you.